Give me 25 minutes, I'll give you the last IUPAC naming video you'll ever need. Hey there, ninjas. This video is in a series of videos on IUPAC naming. We started with the basics and all of the rules. If you'd like a refresher on those, I encourage you to watch those videos before starting this video. The next set of videos looked at alkanes, alkenes, and alkynes, molecules with basic saturation, and cyclic molecules. You should feel confident with the setup of a basic IUPAC name. So if you'd like some more practice there, I'd encourage you to watch that set of videos before watching this one. As a brief refresher, every IUPAC name is composed of 5 parts. We start with any stereochemistry information, followed by the substituents, and then a syllable for the parent hydrocarbon, the unsaturation, and the priority functional group. Not every molecule has stereochemistry, and not every molecule has substituents. But every IUPAC name needs a syllable for the parent, the unsaturation, and the priority functional group. Up until now in this series, we've been avoiding molecules with a priority functional group. And as you move forward in the course, you'll get to a chapter on alcohols and on ethers and on carbonyls and aldehydes. And most textbooks like to teach the naming of those functional group molecules at that point in time. I don't think we need to make it that complicated. Having a molecule with a priority functional group doesn't change all of the IUPAC rules. It just changes the suffix needed at the end of the IUPAC name. The only thing we really need for this video is this table here. This table was introduced back in the rules video, and it lists all of the functional groups we're likely to encounter in organic chemistry in priority order. If a molecule has more than one functional group, there can only be one priority functional group, and it'll be the functional group that's highest up on this list. That functional group will get the suffix syllable at the end of our name, and any other functional groups will be listed as substituents in order in the name of the molecule. So we don't need a new set of rules with every functional group, we just need to find its place on this list and slot in its syllable as a priority functional group. In this video, we're going to work through several worked examples of IUPAC naming. We're going to see molecules with all sorts of different types of functional groups, and we'll show you how to name them from the relatively simple up to the fairly complicated. Let's get started. The rules for IUPAC nomenclature don't change just because we have priority functional groups. The first step is to find the longest set of consecutive carbon atoms containing the priority functional group. In this molecule, the ketone is the priority functional group, so we need to find the longest set of carbon atoms containing the ketone. And for this molecule, it doesn't really matter which direction we go, we can find a chain of 4 carbons that contains the ketone. The next step is to number the molecule to give the priority functional group the lowest possible number. That means for this molecule, we'll number right to left to give the ketone the lowest number at carbon number 2. The next step is to name the parent hydrocarbon from which the name of this molecule will be derived. There are 4 carbons in the longest consecutive chain. Our name for our 4-carbon hydrocarbon is butane. But this isn't going to be a butane, is it? This molecule does have a priority functional group. We need to change the last syllable of our molecule to account for the priority functional group. Based on our previous chart, when there's a ketone as the parent, we update the name of the molecule and we change that last syllable to O-N-E. This molecule isn't a butane, it is a butanone. In this way, we don't need a new set of rules for every priority functional group, we just need to remember how we update the name of the parent hydrocarbon. Our next step is to list all of the substituents and their positions in the molecule. We'll start on carbon number 2 with our ketone. On carbon 3, we have a methyl group, and on carbon 3, we have another methyl group. Recall that when we have 2 instances of the same functional group, we combine them with a numeric modifier and call this a dimethyl group. Now we're ready to build the name. We start by listing all of the substituents in alphabetical order. The -one isn't a substituent, it's how we updated the parent hydrocarbon to account for the priority functional group, so the only substituent that we have to use is dimethyl. Recall, we do not alphabetize by the D in dimethyl, we alphabetize by the M. It's the only substituent, so it will be first in our name. We would write that as 3,3-dimethyl. We separate numbers from numbers with commas and numbers from letters with hyphens. We list both numbers for the 2 methyl groups even if both methyl groups are attached to the same carbon. If there's 2 methyl groups, we need 2 numbers. Now that we're done with substituents, we run right into the name of the parent hydrocarbon, butanone. The only update we need to make is to include the location number of the ketone in our final name. The official IUPAC rules say to put that number immediately preceding the syllable it is modifying. There was an old version of the IUPAC naming system where we could put this 2 in a different spot. I'm not going to go through that here because those are not the official rules. Although your instructor may allow that, and you should check with your instructor if that would be okay. Putting the location number in the correct place gives us 3,3-dimethyl-butan-2-one. Our last step is to scan back through the molecule, see if there are any stereocenters. This molecule does not have any stereocenters, so the final official name is 3,3-dimethyl-butan-2-one. Pause the video, see if you can find the name of the parent hydrocarbon for this molecule. Alcohols are different priority functional groups than ketones, but the naming rules are still the same. We'll start by finding the longest consecutive carbon chain containing the priority functional group. Here, there's only one consecutive carbon chain and it contains 5 carbons. Next, we number the molecule to give the priority functional group the lowest possible number. In this case, whether we number from the right or the left, the alcohol will be at carbon number 2 either way. The IUPAC rules say that if the numbering is the same from either direction, then we start over and we look for the first non-priority functional group and we give it the lowest possible number. Here, there are no non-priority functional groups. It would still be the same numbering both ways. Our tiebreaker after that is we give the first alphabetical substituent the lowest number. Since both of these are hydroxy substituents, there is no difference in numbering either direction. So our final rule in how to number this hydrocarbon is if it's really just the same from both directions, then it really just doesn't matter which direction you number the molecule. So we can number this molecule left to right, and that will give the alcohol at carbon number 2 and carbon number 4. The next step is to name the parent hydrocarbon. There are 5 carbons in the parent hydrocarbon. Our name for our 5-carbon hydrocarbon is pentane. Next, we update the parent hydrocarbon for unsaturation and priority functional groups. We don't have any unsaturation in the molecule, but we do have a priority functional group, and the way we update the parent name for an alcohol functional group is to change the E to an OL. This molecule is not going to be a pentane, it's going to be a pentanol. But it's not going to be a pentanol, though. Just like with alkyl substituents, if there's multiple instances of a priority functional group, we use those same numeric modifiers to indicate how many priority functional groups we have. So this isn't going to be a pentanol, it's going to be a pentane diol. We use the syllable di to indicate that there are 2 alcohols. Notice also we've reintroduced the E back into the name of the molecule. If we didn't have the E there, we'd have an N and a D right next to each other, and those 2 consonants are really hard to say, pentanediol. So we introduced the E as a vowel separator in the name to make it easier to say, pentane diol. Next, we list all the substituents in the molecule and their positions. Here on carbon 2 and on carbon 4 are the positions of the 2 alcohols. Now we're ready to build the name. First, we list the substituents out in front, but these 2 alcohols are part of the parent. This molecule has no substituents out in front. So we'll end the molecule name with the name of the parent hydrocarbon. After we write pentane, we'll include the location numbers of our 2 diols and end with diol. Pentane 2,4-diol. Again, the previous edition of the IUPAC rules says that you could put these numbers elsewhere, but we're going to go with the official IUPAC rules where the numbers go immediately before the syllable they are modifying. Finally, we scan through the molecule to see if there are any stereocenters. This molecule has 2 stereocenters at carbon number 2 and carbon number 4. This isn't a video about how to assign R and S labels, but carbon number 2 is an R stereocenter and carbon number 4 is an S stereocenter. We finish out the name by putting the stereochemistry information in front of the name in a pair of parentheses, 2R, 4S, pentane 2,4-diol. We list the stereochemical units in numerical order, and we separate the stereochemistry from the name with a hyphen. The official IUPAC name for this molecule is 2R4S pentane 2,4-diol. Let's up the complexity for this next example a little bit. Pause the video, see if you can find the parent hydrocarbon, and decide how it's going to be numbered. This is our first molecule with 2 different functional groups in it. We'll need to be able to identify these functional groups and figure out where they are in our priority ranking system. On the left side of this molecule, we have an ether, and on the right side of the molecule, we have a nitrile. If you recall, ethers are part of a set of functional groups along with alkyl groups and halogens that are freebies. They are non-priority functional groups in our IUPAC system. They will always be listed as substituents, never as the priority functional group. So the priority functional group in this molecule is the nitrile. And the important point of nitriles as priority functional groups is the carbon of the nitrile does count as part of the parent hydrocarbon. That means this parent hydrocarbon has 3 carbons in its longest consecutive chain. Next, we number to give the priority functional group the lowest possible number. That means for this molecule, we'll number right to left to put the nitrile at carbon number 1. Next, we come up with the name of our parent hydrocarbon. There are 3 carbons in our longest consecutive chain. The name of our 3-carbon hydrocarbon is propane. But it's not going to be propane. We'll update the name of this hydrocarbon to account for the priority functional group. That means it won't be propane, it will be propane nitrile. Next, we list the substituents and their locations in the molecule. At carbon number 1, we have our nitrile group, and at carbon number 3, we have our ether group. Recall that to name ethers as substituents, we take the number of carbons in the ether group. Here, there are 2 carbons. The name for a 2-carbon substituent is an ethyl group, but because it's an ether, we don't call it an ethyl group, we call it an ethoxy group. The ETH syllable tells us there's 2 carbons, and the oxy tells us it's a 2-carbon ether substituent. Now we're ready to build the name. We start with the substituents in alphabetical order. The only substituent we have is the ethoxy group, so we'll start with 3-ethoxy, and we end with the name of our parent hydrocarbon, propane nitrile. Here, we don't need a number indicating the position of the nitrile because, by definition, the nitrile will have to be the end of the carbon chain. A nitrile is one of a couple of different substituents where, by definition, it has to be carbon 1, and when it has to be carbon 1, by definition, we can omit the carbon number. That makes this name 3-ethoxy propane nitrile. Finally, we scan through the molecule to find any stereocenters. This molecule has no stereocenters, so the final official name of this molecule is 3-ethoxypropane nitrile. Pause the video, see if you can name this molecule. The first step is to find the longest consecutive chain of carbon atoms containing the priority functional group. Here we have a carboxylic acid and an alkene. The carboxylic acid is the highest functional group on our list of priority functional groups, and this 4-carbon chain is the longest consecutive chain containing the carboxylic acid. The next step is to number the carbons to give the priority functional group the lowest possible number. Since the carboxylic acid must be at the end of the carbon chain, by definition it will have to be carbon number 1. The carboxylic acid is another functional group where the functional group by definition must be at carbon number 1. Next, we name the parent hydrocarbon. There are 4 carbons in the longest consecutive chain. The name for the 4-carbon hydrocarbon is butane. But it's not going to be butane, is it? Here, we'll update the name both for the unsaturation syllable and the priority functional group syllable. It's not going to be butane, it's going to be butene. Updating the AN to an EN tells the reader there's a double bond in the molecule. But it's not going to be a butene either, is it? We'll update the last syllable of the molecule to account for the carboxylic acid, and we'll name it a buteneoic acid, 2 words. For a carboxylic acid, we modify the end of the name into oic acid with a space in between as 2 separate words. Next, we list the substituents and their location numbers in the molecule. On carbon number 1, we have our carboxylic acid, and on carbon number 2, we have our alkene. Now we're ready to build the name. There are no substituents in this molecule, so we go straight to the name of the parent hydrocarbon. We start with bute, and then we list the location of the alkene, and we end with oic acid, 2 words. Bute-2-ene-oic acid. Notice there's no number indicating the position of the carboxylic acid. The carboxylic acid, by definition, must be the end of the carbon chain, and when it must be at carbon number 1, we're allowed to omit the number symbol. Finally, we scan through the molecule to account for any stereochemistry labels. Here, the alkene does have E and Z geometry, and we need to account for that in our IUPAC name. This isn't a video about how to label alkenes as E or Z, but this alkene is an E alkene. We put the stereochemical descriptor in front in a pair of parentheses, so this is 2E-bute-2-ene-oic acid as the official IUPAC name for this molecule. Pause the video, see what you can do with this example. The first step is to find the longest consecutive chain of carbon atoms containing the priority functional group. This molecule contains an aldehyde, a bromide, and an alcohol. The halogen, along with alkyl groups and ether groups, are the freebie substituents that are non-priority. And between the alcohol and the aldehyde is the higher priority functional group, so the aldehyde needs to be on our longest consecutive carbon chain. There are 2 chains that contain the aldehyde. Both of them are 4 carbons, so we can use the carbon chain in the plane as our parent hydrocarbon. Next, we number the molecule to give the priority functional group the lowest possible number. The aldehyde is the highest priority functional group, and by definition, it must be on the end of the molecule, so it must be carbon number 1. Next, we name the parent hydrocarbon. There are 4 carbons in our longest consecutive chain. The name of our 4-carbon hydrocarbon is butane, but it's not going to be butane. To update the name of the butane for the aldehyde, we change the E to an AL, butanal. Next, we list the substituents and their locations in the molecule. On carbon number 1, we have the aldehyde functional group. On carbon 2, we have the bromo group. Recall that for halogens, we take the name of the halogen and we add O on the end, and this becomes a bromo group. On carbon 3, we have the methyl group. And on carbon 3, we also have the alcohol. In a previous example, the alcohol was the priority functional group. Here, it is not the priority functional group. That's why our table from the beginning of this video had a column for how we name the functional groups when they're substituents and not the priority functional group. For an alcohol, we name it as a hydroxy substituent. Now we're ready to build the name of the molecule. We start by listing the substituents in alphabetical order. The Al for the aldehyde is included in the parent hydrocarbon, so we'll alphabetize bromo by the B, methyl by the M, and hydroxy by the H. That means we'll start with 2 bromo, 3 hydroxy, 3 methyl, bute, and al. Finally, we scan through the molecule to find any stereocenters. This molecule has stereocenters, but only 1 chiral center. Only carbon number 2 is a stereocenter. Carbon number 3 has 2 identical methyl groups attached and is not a chiral center. Carbon number 2 is an R stereocenter. We put that out in front in a pair of parentheses separated by a hyphen. The official IUPAC name for this molecule is 2R, 2-bromo, 3-hydroxy, 3-methyl, bute, and al. Pause the video, see if you can find the parent hydrocarbon for this molecule. Watch through this example how the rules don't change just because a molecule looks more complicated. The first step is to find the longest consecutive chain of carbon atoms containing the priority functional group. Here we have an ester, a nitrile, an alkyne, and a halo group. The halogen is a non-priority functional group and a freebie and won't count towards our system. The alkyne is the lowest possible priority group, and between the nitrile and the ester is the higher priority functional group, so we need to find the longest consecutive chain of carbon atoms containing the ester. For this molecule, it will be the 5 carbons that start with the ester and go through the alkyne. The next step is to number the molecule to give the highest priority functional group the lowest possible number. The ester is another group that by definition must be carbon number 1, so we'll start with the ester and number through the 5 carbons in the molecule. Next, we name the parent hydrocarbon. There are 5 carbons in our longest consecutive chain. The name of our 5-carbon hydrocarbon is pentane. But it's not going to be a pentane. Because of the triple bond in the molecule, it will be a pentyne, but it's not going to be a pentyne either. The ester is our highest priority functional group, and we need to update the end of the name to represent the priority functional group. For an ester, that means we update the end of the molecule to replace the E with an OH syllable, pentyne-OH. Next, we list the substituents and their locations in the molecule. For esters, we need to recognize there's a carbon chain on the other side of the oxygen. And for this molecule, on that oxygen, we have a methyl group. On carbon number 1, we have our ester functional group. On carbon number 3, we have the nitrile. It's not the highest priority functional group here, so we name a nitrile as a substituent as a cyano group. On carbon number 4, we have our alkyne, and on carbon number 5, we have our fluoro group. Now we're ready to build the name of the molecule. And we begin the molecule with the name of that alkyl group. Since there's 1 carbon on the other side of oxygen, we start the name of the molecule with methyl. For esters, once we list that carbon chain, we leave a space and we move on to list the substituents of the molecule in alphabetical order. We've already taken care of the methyl group. The OH is part of our parent hydrocarbon name. We'll alphabetize by the C in cyano and the F in fluoro because the YN is also included in our parent hydrocarbon. C comes before F, so we'll have a space in the molecule and then 3-cyano, 5-fluoro, pent, 4-ine-OH. We need the number 4 to indicate the location of the triple bond, but we do not need the number 1 for the ester because by definition, the ester must be at carbon number 1. Finally, we scan the molecule to look for any stereocenters. Carbon number 3 is a stereocenter in this molecule, and it is an S stereocenter. That means we update the beginning of the name with the stereochemical information. The final official IUPAC name for this molecule is 3S-methyl, space, 3-cyano, 5-fluoro, pent, 4-ine-OH. Pause the video, see if you can name this next example. Our first step is to find the longest consecutive carbon chain containing the priority functional group. Here, the ketone is our higher priority functional group over the amine, and so the 6 carbons in the ring will be our parent hydrocarbon. Next, we number the molecule to give the priority functional group the lowest possible number. For a cyclic molecule, we can put carbon number 1 wherever we want, so by definition, we'll put the priority functional group at carbon number 1, and we'll number to give the next substituent the lowest possible number. Now we're ready to name the parent hydrocarbon. There are 6 carbons in our hydrocarbon, that would be hexane, but it's not going to be hexane because the 6 carbons are not in a linear chain. They're in a ring, so this will be updated to cyclohexane. But the name of our parent hydrocarbon isn't going to be cyclohexane either, is it? Because we have the priority functional group in the ketone, we'll update the end of the molecule name and we'll call it cyclohexanone. Next, we list the substituents and their location. On carbon number 1, we have the ketone functional group, and on carbon number 3, we have the amino functional group. Amino is the way we list an amine functional group when it's a substituent on a parent hydrocarbon. Now we're ready to build the name. The one is part of the parent hydrocarbon. The only substituent then we have is the amino group, and it will go out in front as 3-amino. And then the name of the parent hydrocarbon, cyclohexanone. Normally, we would need a number to say where the ketone is, because the ketone doesn't have to be at the end of a linear hydrocarbon. But this isn't a linear hydrocarbon. It's a cyclic hydrocarbon. And by definition, the highest priority functional group gets to be carbon number 1 in a ring, so we do not need the number 1 for the one in this molecule. Finally, we scan the molecule to see if there are any stereocenters. In this molecule, carbon number 3 is a stereocenter, and it is an S stereocenter. We put the stereochemical label in front as 3S, separated from the name of the molecule with a hyphen. That gives us the official IUPAC name for this molecule, 3S, 3-amino, cyclohexanone. Pause the video, see how far you can get with this example. As always, our first step is to find the longest consecutive carbon chain containing the priority functional group. In this molecule, we have an amide and an aldehyde. Of the two, the amide is the higher priority functional group, so our longest consecutive carbon chain will need to contain the amide. These 3 carbons are the longest consecutive carbon chain containing the priority functional group. Next, we number the molecule to give the highest priority functional group the lowest possible number. By definition, the amide will have to be the end of the molecule, so we'll start with carbon number 1 and number through carbon number 3. Now, we name the parent hydrocarbon. There are 3 carbons in the longest consecutive chain. The name of that hydrocarbon is propane, but it's not going to be propane because there's an amide in the molecule. The way we update the end of the molecule is to add amide. Propan, amide. Next, we list the substituents and their locations in the molecule. For amides, there are alkyl groups on possibly both sides of the nitrogen. The way we name those substituents is we use the location as an N, followed by the name of that alkyl substituent, N-methyl. It's hard to draw on a screen, but this N should be italicized, N-methyl. On carbon number 1, we have our amide, and on carbon number 3, we have our aldehyde. The aldehyde is not the priority functional group in this example. But going back to our table at the beginning, an aldehyde as a substituent is named as an oxo substituent. That's all the substituents in this molecule. Now we're ready to build a name. We'll list the substituents in alphabetical order. For N-methyl, we'll use the M in methyl. The amide is contained in the parent hydrocarbon, and we'll alphabetize by the O in oxo. We start our IUPAC name then with the italic N, methyl, 3-oxo, and then the name of our parent molecule, propanamide. That gives us N-methyl 3-oxo-propanamide. Finally, we scan through the molecule to see if there are any stereocenters. This molecule does not have any stereocenters, so this is the official IUPAC name for this molecule, N-methyl 3-oxo-propanamide. All right, ninjas, last example. This one is certainly the most complicated. And if you see this on an exam, you can take a deep breath because the rules don't change just because the molecule looks complicated. The first thing to do is find the longest consecutive chain containing the priority functional group. There are a lot of functional groups in this molecule, but only one of them can breathe the priority functional group, and that will be the carboxylic acid. So the longest consecutive carbon chain containing the carboxylic acid will be these 8 carbons right down the center of the molecule. The next step is to number the molecule to give the highest priority functional group the lowest possible number. By definition, the carboxylic acid must be the end of the molecule, so it will be carbon number 1, and we'll number the rest of the molecule right to left. Now we can name the parent hydrocarbon. There are 8 carbons in our parent hydrocarbon. Our 8-carbon molecule is octane, but it's not going to be octane, is it? We have unsaturation and a priority functional group in this molecule. Therefore, we'll update the name of this molecule. It's not going to be octane. Because of the alkene, it will be octene, but it's not going to be octene either because we have an alkene and an alkyne. When we have both the alkene and the alkyne, we update the name of the molecule to be octene-ine. But it's not going to be octene-ine, is it? This molecule has a priority functional group, so we'll drop the E and add the oic acid for the carboxylic acid. The name of the parent hydrocarbon for this molecule will be octene-ine-oic acid as a second word. Now we can list the substituents and their locations. On carbon 1, we have our carboxylic acid. On carbon 2, we have an alcohol. As a substituent, we call that a hydroxy group. On carbon 3, we have the nitrile. As a substituent, we call that a cyano group. Also on carbon 3, we have our alkene. On carbon 4, we have our amino substituent. On carbon 5, we have our bromo substituent. On carbon 6, we have the ketone. As a substituent, a ketone is named as an oxo substituent. And finally, on carbon 7, we have our alkyne. Now we're ready to build the name of our molecule. For all of these substituents, we'll alphabetize by the A in amino, the B in bromo, the O in oxo. The ine and the oic acid are already part of the parent hydrocarbon name. We'll alphabetize by the H in hydroxy, the C in cyano, and the ene is part of the parent hydrocarbon. So building the name of this molecule, we'll start with 4 amino, 5 bromo, 3 cyano, 2 hydroxy, 6 oxo, oct, 3 ene, 7 ine, oic acid. 2 words. Notice that because the carboxylic acid must be carbon 1 by definition, we do not need to include the number 1. We finish by scanning through the molecule to find any stereochemistry. Carbons 2 and carbons 5 are chiral centers, and the alkene will have E and Z geometry. Carbon 2 is an R stereocenter. Carbon 5 is an S stereocenter. And our alkene is a Z alkene. We put all of that in front of the molecule in a big set of parentheses, and we put it in numerical order. 2R, 3Z, 5S, separated from the rest of the molecule with a hyphen. Therefore, the official IUPAC name for this very complicated molecule is 2R, 3Z, 5S, 4 amino, 5 bromo, 3 cyano, 2 hydroxy, 6 oxo, oct, 3 ene, 7 ine, oic acid. Now that's an IUPAC name. But notice, no matter how complicated the molecule got, the rules stayed the same. The only thing we needed to do was remember the specific syllable for the priority functional group and a specific syllable for the functional groups when they are substituents. As long as you have your priority functional group list, you don't have to memorize different rules for every different functional group. If your instructor teaches nomenclature with each new chapter, now you'll be ahead of the class and be able to treat those lectures as a nice review. If this IUPAC system is starting to make sense, the next video you should watch is IUPAC naming of benzene derivative. The way we go about the naming changes ever so slightly when our parent is a benzene ring. Great work today, ninjas. I'll see you in the next video.
I'm glad you're here with us for this training today. Check out these other videos in my playlists to see if there's anything else that can help you level up your ninja levels even further. As always, don't forget to like and subscribe.